Okay guys, I'm not back. I'm just kind of streaming so that way you know I'm here, that I haven't dropped off. I'm just going on a bio break and I'm breaking up the video into a couple of sections. So I've kind of come off and now I'm back, just temporarily, as we're going to wait for about 10 or 15 for us to come back to the ultra coding. Okay, so I'm going to leave it right here for you and I'll be back. All right. So I'm back. I'm just waiting for the rest of you to come back. And again, I want to pause for a bio break. Some of you need to do some smoking, do other kind of stuff. Again, I'll edit this part out for those of you who are watching live. Oops. So I'm hoping that you guys have been working on some of that assignment number 2. Some of you have. I know that. And we'll see if, as we move forward, if we can talk about assignment number 2 a little bit more today. And that might be really part 3 of the video. We'll see how it goes. All right. I'm going to take a look here at some questions. I think I have a couple questions that I'm going to kind of deal with right now. One of the questions I have here as we're waiting for everyone else to come back is, do we need to have an input text, or can we just have it says pre-amount buttons, the bet an assignment? And the answer is for assignment 2, you can have preset buttons if you want. We'll wait a few more minutes, 4 or 5 minutes more before everyone comes back, and they'll give a chance for everyone to come back from their break if they're actually taking it. And the question is, if you use preset buttons, will you lose points? And I'm going to say no. No, presets are okay. They control and validate your input to some degree. Okay, answer a couple questions. I'm just going to wait a couple more minutes and then I'm going to start again. Say a few more minutes anyway. And right now I'm monitoring the chat just as we move between our breaks here. And again, what I'm probably going to do, like I said, is have another little break around the 10 to time as well, just to break it down so that it's not more than, let's say, 45 minutes or 50 minutes at a time where we're online. And part of that is because from a YouTube perspective or even a Ustream perspective, we don't want it to be, the files to be so large that they're unviewable. And part of it is there's going to be chances where I'm going to edit some of this stuff down, pare it down, for those of you who are going to be watching, and you're not going to be watching live like we are right now. Okay, looks like we're cycling. And we're going to see how this thing continues to move forward. All right. Okay, so it's about 10 minutes past 12, and on my time, anyway, my clock, your clock may show a little bit later than that because there is a delay between the time that it shows on my clock and yours because we're streaming. Okay, so we talked really about the alter framework before break, right? Or came back to our presentation here. And we went kind of through it. We went through the assigning the values to key variables. We talked about setting up the main loop and so on. Setting the timer to 30 frames per second, and by chance mine was set to 60 because I think in previous class I had set it to 60 to kind of show you that it does work. But I don't recommend you keeping it at 60. I think 60 is a little bit too crazy for mobile devices. It's fine for the desktop. It will move things a lot faster. But if you're going to have it at 60, let it stay at 60 for the whole time. Okay. Let me just flash out of this this view that I've got here, because right now I've kind of got my picture, which you don't really need. So I'm just going to turn that picture off and move back to the presentation. Okay. And then we talked about the event handling and how when we create, just as a refresher, the event object, what we're really doing here is we're instantiating an event object by using this code right here, pygame.event.get. Once we've done that, this event object we can use methods. For example, the event.type method. What type of event are we listening for? And like we said, we're listening for that pygame.quit event, which is linked to the X on our window. Okay, that's really what it is. Okay, I see a bit of a break. It looks like an ad. So here's another ad that I'm going to wait for now. And again, this is what happens when you have ad-supported stuff. So I'm taking a break as we speak. And again, we're going to edit this portion out, hopefully on the video, where you can go back over it later on. And the first ad is almost finished. I'm just going to go to the second ad. Yeah, here we go. Well, it's actually a different ad this time. I'll look at the chat, by the way, and see if there's any other users that have any other questions online here. And it looks like for those users online, I can tell you that we will be talking about assignment number 2 today, again, just to discuss certain issues and talk about Tkinter. I'll show you some quick steps that you can use for Tkinter if you're going to use that framework. And we're back. Okay. So we've got this, this framework, and again, this is just a way of us setting up our game. And again, it could be in Pygame. It could also be in Tkinter. You could also use other frameworks as well. And I'm mentioning the other ones because I don't want you to think that Pygame is the only one that I will accept. As long as you tell me for your final assignment which framework you choose to use, I'm good. Now, I don't recommend, I'll tell you this in advance, that you use Tkinter for your main game. You're the final project. I think it's probably something better like Cocos 2D or a Pygame that you can use for your arcade game, because again, Tkinter is very good for a quick and dirty kind of GUI, but for really more advanced graphics and control animation and so on, you probably want to use a better framework like Pygame. Okay, moving on. So we kind of talked these things. Talked about when we initialize these key variables, we're going to assign key variables values like the clock. And we're going to set up the clock at first. We're going to instantiate that clock object and the sentinel variable, which is keep going, right? And here's our loop. We talked about that. Our framework, how many frames we have per second. This is our refresh rate, if you will, every frame. And here's our event handler, right? And again, what we want to kind of do here is, in this particular case, our quit event is going to quit us out of the the application itself. But there may be other events in this particular if, else loop that we're going to be creating in the future that we're going to be listening for as well. And we're going to do that every frame. Here's where we're going to refresh the display, and I think I want to talk about this blit function a little bit more in more detail as we move forward. But really what the blit does is it just shoves everything onto the screen. It actually displays the image, right? When we flip the image, what we're doing is we're using double buffering to help us manage any movement across the screen. Okay, but we need both of those methods, both the blit, and if you know, screen is what we're blitting. So we're actually blitting the background on our top level window. So again, if you think about our screen as a top level window, and the background is just a frame, if you will, or some kind of a surface that we're defining on our top level window, we're actually displaying that. Again, we're almost redisplaying this thing or refreshing the background onto our screen again. And then we're using this display flip to actually double buffer it, to actually give it more memory, so that when we do animation, that there's not as much lost frames, if you will, and jitteriness. Okay. Okay, and here it is. We just talked about it, right? Blit is short form of bit blit, which is, like it says here, a type of binary block transfer, which actually displays everything on the image on the window, right? We can actually blit images into new positions, and you'll see that as we move forward, we're going to display graphics, sprites into new positions as we do our updates. And again, double buffering allows us to reduce flicker, like I said, when it comes to animation. Okay. So again, we use this additive color module, or model, if you will, when it comes to defining colors. There's two different ways we can do it. Actually, there are three different ways. We have RGB type of color, red, green, and blue, right? So we can actually say, we can use base 10 to define them. So we can say 0 to 255 for our red value, or our green value, or our blue value. Or between 0x00, which is hexadecimal, and 0xFF, which is base 16, hexadecimal way of defining our values in terms for color. So this is a great control. It gives us a lot of control for different amounts of color when it comes to defining shapes and custom objects that are not images. So let's say we want to define a rectangle. We want to define color, the surface of the rectangle and its color, right? We can define it as red, the amounts of red, green, and blue that we use for these for the rectangle itself. Okay. So, and again, it's true. Web developers are definitely more comfortable with hex color schemes, and we're going to see that when we use CSS on the web. We use the pound sign and then, again 6 digits to define our type of color. So let's take a look at this colorviewer.py for some interactive examples, right? And I'm going to shift back now to Aptana so we can see how that works. Okay, so I'm shifting Aptana. I'm closing down this idea.py program, and I'm going to pull up colorviewer.py. So let's take a look at this code a little bit more carefully here. And a great thing about Aptana is if you double click on this top part, you actually see just the code, and there's no other view for it at all. So it actually makes this the main part of our screen. Okay, so again, we're doing a couple things. Here's our import. The I part of our idea framework. We're actually importing and initializing. Here's our Pygame.init. We're doing that too. Right now we're displaying. So here's our screen. Right, so we're displaying 640 by a 480 window. We're changing our caption though. To say color viewer, use arrows to pick colors, spacebar to switch between hex and decimal. Kind of cool. Okay, we're creating our background surface, and the background surface is initially going to be, and here we're using hex 0x00, 0x00, 0x0, and 0x00 as our base hexadecimal version of our colors. So again, we can, if you notice the last piece of code that we used, it used decimal versions of this. So 0, 0, and 255. In this particular case, we're making it 0, 0, and 0, which to me, if you turn all the color off, what does it mean? It means it's going to be black, a black background. We're also defining something called a name font. All right, so here, a name font, we're actually creating a new object for our on our view, right? And this is how we do it. We say name font as the object that we're instantiating. We're using our Pygame framework to create a font. We're using the font method or font class, and we're using the sysfont method to create an Arial type font. This is a typical font that we have in our system of 12 points. Okay, so that's the first thing. That's what a name font is going to be, and we're defining kind of some attributes of that font. And if you hover over it, if you notice, there's actually other attributes you can define. If you notice, there's some name, the size, if it's bold or not, italic or not, and so on. Right. So if you notice, if you go to the Python documentation or Pygame documentation, sysfont actually has a series of different options that you can put in here. And similarly, we're actually creating this number font idea here, right? We're actually creating for the name, we've got for their name label, we're going to use one type of font, and for a number font, where you can use something else. We're going to use Arial, but the size is going to be 20. So if you notice, we can't just change the size of the font on the fly, so to speak. We have to kind of define these variables ahead of time. So at the beginning, we're going to set a display mode variable to set a decimal. So that's the display mode that we're going to set up as. Okay. And now here we get into some stuff that we've never seen before. We haven't talked about it yet on the Python side. We're going to actually use a class to create this this code here. And again, we're going to go over this in more detail. But in our class, we define with double underscore here, where it's a double int right here, underscore int in it, double underscore, and then self, and then color name. We're going to talk about this later on. This is actually our constructor. Right here. So this is where every time this class color label is instantiated, it's going to call the constructor. It's going to do all this stuff all at once, right? And then we've defined one method for our class, and here's how you define methods. Just the short form. Every time we call the update function or method, all this stuff is going to happen, right? Here's another one. Here's increase color method or decrease color method. There's a bunch of methods that we're going to use in this class, and we also have. Actually, this is the actual class itself. And again, anything that's tabbed, we're going to use the tab. Remember, Python uses tabs for creating our code block. So anything that's in the same tab level is going to be included in our class. Okay, so all the way down. Okay, and then we have another function that's outside of our class that we can call, where we can actually call different built-in classes to Pygame. And here we're just drawing a bunch of lines. Right, a bunch of lines are being drawn. We're going to call this method, this function, right? And here's some color labels that we're defining. These are, and I talked about global variables before. I said, hey, global variables are bad, right? That's a bad thing to do. But if you notice, all this is inside my main. So this is in my main function. And again, theoretically, if you think about it now, right, anything that's in my main function that's like these variables here are global to just main itself. Okay, so these are setting up some color labels here, and again we're defining the this variable CL red, which is a color label. Or actually, this is calling this function color label red. Okay, and if you notice, color label itself is the class, right? So we're calling the class. We're instantiating, right, this new object, this color label red, and we're saying it's red. That's the color label we're creating. We're also defining some properties of the class. We're saying, well, the center of the rectangle of this particular class is 200 by 200 pixels. That's exactly the area on the screen that we're going to draw. And we're also saying the color. We're going to say whether it's selected or not. So we can actually set selected to true, which we've defined up here as one of our methods. So these are our methods to say it's true. So this particular color is initially selected. Okay, we're going to do the same thing for color green and color blue and so on. We're going to go over how to use classes and so on as we move forward from a syntax perspective in Python. But again, up until this point, you being the programmers that you are, you've gone through several different kinds of classes in terms of programming to understand object-oriented design, and you're going to see that we're accessing these methods by using the dot accessor, right? So that's our accessor type, dot. There's different types in different languages, but that's the method that we're going to use when we're defining methods, how we use methods of classes in Python. So we do that. We set the sentinel variable to true, right? And we say we've created this other variable called all sprites. Here's something we haven't seen before. And actually what we're doing is, even though these color labels, we're defining these 3 color labels, we're actually using them as sprites. These are all 3 different sprites that we're going to kind of group together in this all sprites group. And we're using this pygame.sprite render updates method to group all these sprites together. And again, you don't have to remember all this stuff right now, but this is what we do to group sprites together. We want all the sprites to be kind of grouped in this particular case. Okay, and if you noticed before, like I said, you've got your main event loop right here, and you're listening for a quit. But you're also listening for a type of key down event, right? that you're listening for in here. So you're listening for, if it's the space, you're going to switch between decimal and hexadecimal, and if again you do it again, it's going to go back to decimal. Okay, we're going to break for a second while the ad is going on. Right, so I see an ad on my side, and I'll check the chat as I'm going to see, make sure that anyone has any other questions right now. And again, even though I'm going through some of this stuff right now, it looks like a lot of advanced stuff that we haven't covered. We're going to cover it again going forward anyway. Okay, so the first ad is done, and we're getting into the same second ad for another 30 seconds. Again, apologies for those people who are watching online. They have to see this ad-supported stuff, and you may or may not see it at the same time, depending on where you're connecting from, and the type of ad might be different. I'm seeing a bell ad. All right. And we're back. Okay, so there's no more ad. So again, this is your main event loop, and if you notice, there's some nested if statements in here that actually check for other type of events that go on. You're checking for different things, different types of events. For example, Pygame.kLeft, which we're going to detail later on when we do events, actually is the left arrow, and that's what we're listening for. We're listening for the red arrow when we listen for it. In this particular example, if the current color is red, then we want to shift it to blue, and if it's green, we want to go back to red. So basically cycles through different the color sprites and makes them selected depending on which color is the one that's current. Okay, so we do all these different kinds of events, and then what we're going to be creating another variable, another object. We're going to say Pygame.key.pressed is equal to key. So whatever the key that's pressed is, we're going to capture it and put it in this keys variable. That's what this thing does. And then if keys, we're going to check what type of key it is, if it's up or down, and then we're going to do different things. We're going to access the increased color method of the color label class, and we're going to do the same thing for the decreased color label method, depending on if I press the up or down arrows. Okay, we're going to fill the background with the red, green, and blue values that we've defined, right? And again, we're defining them as we go. So the background is going to change color as we move the bars up and down. Then we're going to draw bars, and draw bars is a separate function. Remember, it's outside of our class. And draw bars actually it's going to take a line. It's going to draw the background with the type of color that we're looking at. So it's going to draw the bars the way we want them to. And if you notice, there's a bunch of different variables here. If you look at the line has a couple things. It has surface that we're looking for, the type of color. So here's a color, RGB, right, in hexadecimal. And it also has our start position. So here's our start position, 200, 350. This is our first line that we're drawing. And then our second or end position, which is 200, and then 350 minus 255, which is actually a calculation that we're putting in here for the second endpoint. Then also we have the last parameter, which is 3, right, which is the width of the line. In this particular case, it's a width of 3. So it's kind of a thicker line. We get some thinner lines that we're defining. It's almost like we're actually drawing the 3 bars. So there's one that's going to be up like this, another one, and so on. And we're going to see that. So we're actually using this draw bars function to draw our the object on our screen. Then we're going to refresh the screen, and this is going to happen every frame. And then what we're going to do is we're going to say we're going to clear the sprites, we're going to update the sprites within the new positions, and they're going to redraw the sprites back onto the screen or the main window. And then we're going to display flip, which means again we're going to add that double buffering to make sure that when we do any kind of changes or update the screen, it's going to do this nice and smooth without jitter. Okay, so let's see how that works. I'm going to double click on this to go back. Okay, and we're going to press play here to see how that looks. All right, so here's our 3 bars, if you notice, right? And again, right now red is highlighted, right? If I move I'm just going to click on my right arrow, and I can switch between red, green, and blue. I can highlight the different bars here. And if I press my up button here, when red's highlighted, if you notice, I can increase the amount of red color that I'm using. I can switch back to green. I can increase the green, and my background is going to switch. It's going to switch my it's going to change the color according to whatever color I choose. And again, this is updating every 30 frames a second, so it's happening fast enough. So if I move my mouse, we're going to see it almost what it appears to be instantaneously. And again, we're also listening for this quit event, so we can actually exit out of this program. Okay, so we've all done that, and that's again a preview of what classes look like and everything else. We'll get back into this in more detail, and we'll also cover this a bit into Kinter. Let's go back. All right, so let's take a look at this thing now. So we've looked at the color viewer. We use the spacebar to switch between, we didn't do that. We didn't switch between decimal and hex number. But that just basically changes. Instead of a decimal number on the program, actually I'll just do that now. Switch over to this and run it again, so we forgot to do that. Okay, so again, if I use a spacebar, now it's going to change to hex. If you notice, here's the hex. So if I increase that, it's going to change to whatever hexadecimal value is going to be representative in that particular case. And if I just turn this all up and get that out of the green color, that's what it looks like. So let me just exit out of that. So that's one of the things I didn't do. Okay. So that's what the spacebar does. So we're actually listening for a bunch of different keys. We're listening for the arrow keys. I'm listening for the spacebar, and I'm also listening for the mouse button when I click on the X. So those are the different listening events that I'm doing here with this colorviewer.py. So, okay, very neat little program for what it is. Okay, so imagine if we need to move an object, right? We begin with this idea alter framework. We start off, we define, we initialize, and we import our Pygame framework, or we do it into Kinter. We display the screen. We set up the display and configure it and see what we want, right? And then we start defining our entities, and then we talk about our action framework. Say I start defining our we set up all of our variables. We set up our loop, right? The game loop. And then what we do is what we want to do is we talk about our timer, right? That's really what the alter framework is about, right? And what we really want to do is we want to set up a way of doing stuff. It's all that we've just set up. We do all the setup ahead of time, and then what we want to do is we add a box entity. We'll talk about this in a second. We're going to add variables to describe the box position, and inside the loop, we're going to manipulate the variables inside that loop, and then we're going to redraw the background, redraw the box in a new position. Right, so that's how we're going to do. So let's take a look at movebox.py. Here's a great example for Pygame. All right, so let's go back, and again, if we look at the idea framework, we're still going to use the idea framework, but we're going to do it with this other program called movebox.py. And if you notice, when we switch back here, here's movebox.py on the right. We're going to do that, and each of these pieces of code is commented nicely, so you know when to use the idea framework. So here's initialize, display. Here's your entities. You can define your background and so on. Here's your action, where you're going to assign. You're going to your different variables there. Your loop, your timer, your events. We're going to do some event listing, and then of course the R is we're going to refresh the screen. That's really what we want to do. Okay, so it's all set up in the same way, and if anything, if you erase all this stuff and you can put it all back, as long as you follow the same methodology, you're not going to have any errors when you're going to create your code. Okay, so let's talk about this again. So we're initializing. This particular case, it is 640 by 480 again. We're going to display move a box in our title bar. This is what this is going to do. We're going to create the same kind of surface object. It's going to be the same size as the width of the top level window. All right, we're going to convert it to Pygame or Python compatible code. We're going to fill it with red and green together. What's red and green together? Without blue, right? A yellow background, right? That's what this is. And we're going to create a couple of objects. We're going to say box as a variable is equal to a new surface. So here's a surface up here, right? Pygame surface. Well, here we're defining another surface, pygame.surface here, right? So it's a box, and the box size is going to be, if you notice the surface size, here we defined it the size of the screen get size, right? Well, here we're defining the object, the surface object, right, as, if you notice, we're defining it as 25 by 25 pixels. So it's quite a small box. We're converting it to Python compatible object, and then we're filling it with a red color, right? That's what 255 is. Again, we could have used hexadecimal here instead of red, or the 255 here, but it's the same. Okay, and then we're going to set up some variables. We're going to say, well, the x value of the box is 0, so the x is where it appears horizontally on your screen. So x would be the leftmost border of your screen, and box y would be the, this is where we're going to set up our y variable, our vertical position of the screen, right? This is where we're going to set this box up, which is 200 pixels down from the top. Remember, our coordinate system is 0, 0 on the top left corner of our screen. Okay, and then here's our action. We're going to assign some variables. Here's the clock variable, again, just like before. Our keep going sentinel variable is equal to true, and then here's our main game loop, right? We're going to set our frame rate to 30, and then we're going to listen for, the only event we're going to listen for is this quit event that we're going to, for our mouse to click on the X, right? And here's where some changes happen. So inside of our loop, before every frame that we're going to do, we're going to actually increase the X component, so the horizontal positioning of the box, by 5 pixels. We're actually going to move it to the right 5 pixels every time every frame, if you will. Okay, and if box X is greater than screen get width, what are we doing here? When we use the screen get width, or actually the screen again, we've defined it as our top level window. When the X coordinate of the box is greater than the width of the screen, well, you know what? We're going to reset the box to the leftmost corner again. So it's going to look like the box is going to go from one end of the screen, it's going to travel across to the other side of the screen, and then it's going to loop again. That's what it's going to do. Then we're going to blit the background 0, 0, right, and the box wherever the box X and box Y coordinates are here in this particular case. And we're going to flip the screen, or use double buffering to display the screen again, so that there's no any kind of jitter on the screen again. Okay, so let's take a look at this. So we'll run the code. And again, you should see this box, and it's moving to the right of the screen. It's a red box, and as you notice, as it goes, I'm going to trace it with my mouse here. As it goes to the right edge of the screen, just like we do here. You notice in the code, here's our code. Here's our we're checking. Here's our check right now, checking boundaries. If the box X, the X coordinate of the box, right, is greater than the screen width, then we're going to start over here again. Right, that's what we're doing. So we're going to reset it to 0. 0 again being the leftmost portion of the screen. And that's what we're going to do with that X coordinate. So it's quite a simple program. If I just exit out of here. Now if I change the box X plus equals to value, if I change it to 10, I want it to move a little faster, and I run it again, and again my program is going to run a little faster. And if you notice, it's going to go twice as fast, right? I haven't changed my clock tick here. My clock tick value is still 30 frames per second. And if I change that, let me just change that as well. So I go back to, I stay at 10, and I change it to 60 frames per second, right? And I run it. Let's take a look. It's going to go twice as fast again, right? So that's another way of increasing the speed. But this way, this second way that I've increased by changing the clock or the frame rate is bad, because that means all objects in my game are going to increase or double the speed, which is bad. And I really would be careful doing this anyway, because if you do this programmatically, so in game, and let me just pause again for our commercial break. Again, I'm trying to bear with it as well. Okay, so the first is done, and now we're into the second ad. Some of you may or may not see it, like I said before. Bear with it, please. All right. And I don't see any other chat, so it looks like you guys aren't asking any questions, which is okay. All right, and we're back. So Okay, where were we? Oh yes. So we're looking at, I've just changed this frame rate back down to 30. So was that, I did change the horizontal value of the box moving from 10, or from 5 to 10, and I'm moving it back. So you're going to see the original value again. If I run it again, here's the original speed of the code. I'm just going to move this to the middle again. It's fairly slow. If I actually slow it down even further, if I move this back down to 1, it's going to be definitely slow. Right? Let's take a look at that now. Okay, so you can modify. I would encourage you to play with this a little bit so you can see how slow it is. And if you notice, it's quite smooth because we're seeing this change happen at 30 frames per second. The persistence of vision of human beings can't detect jitteriness here in this particular case. Now, this is a very slow moving object too. The faster the moving objects are, and the more objects there are on the screen, the more jitter we're going to see in our code. Okay, and it's just a natural, depending on the type of system you have and the way we use Python and Pygame and other kinds of frameworks, you're going to see more or less jitter. Okay, let's just change this back just so we keep consistent with everything else and save our document. Moving back to the presentation. So again, we've created this box that's a red box that's 25 by 25 pixels. Okay, that's how we've done that. We've kind of gone through how that works. And if you notice, these variables, these box variables, you can change them so your box appears at different positions on the screen as well. So you don't have to make it start at 0, the horizontal value. You can make it start somewhere else. And here's our box value, like we said. It's going to increase by 5. We've kind of talked about this as well. But so again, what does it say? It says this doesn't actually move the box. It just changes the variable on the screen. And then what we do is when we update the box right through our loop, this is when the actual motion happens in the refresh step. So every frame. Okay. Boundary checking, and we're going to do a lot of boundary checking going forward. And we're only checking for one boundary, which is the rightmost boundary. As we approach the right boundary, because our box is moving in that direction, this is where we create that screen wrap effect. Okay. And then here again at the bottom, we're using the part of the alter framework is to refresh the screen, where we're going to actually refresh the screen, throw everything back out there, and then display flip, which is using that double buffering. Okay. So we're not going to talk required reading right now because you guys aren't using this book, right? Or you can if you want to get it. Right now, what we're going to do is we're going to shift into the Tkinter portion of our code. So I'm going to quickly break for about 5 minutes. Here we're sitting at my clock, 12:43, and we're going to do the Tkinter portion of our code, and we're going to talk about assignment number 3 over the next video or so. Okay, so I'm just going to quickly pause, and I'm going to come right